GPUs, right? For example, CUDA for NVIDIA GPU and HEAP for AMD GPU. And this makes very challenging to have the performance portability across all the vendors and architectures. This is where OpenMP comes in. OpenMP is a parallel programming model that features the shared memory parallelism, which is widely used in high performance computing. And it features the performance portability and user friendliness, making it a great solution for scientific applications. And this example here shows how OpenMP can be used to offload a for loop to a GPU. And with a couple of lines of code, we can just get significant performance improvement by doing it on the GPUs. And actually, OpenMP dominates the programming model of the exascale computing project, which is responsible for building the next supercomputer for the United States. I am currently being funded by ECP and working on the optimization for OpenMP for the 3 supercomputers. I am also one of the core developers of the LVM OpenMP, which is the most widely used OpenMP implementation of all over the world. We, as the LVM OpenMP community, collaborate with application developers to help to optimize their applications to make them efficient and faster. And especially the OpenMC is a great example here. And I am also the representative of Stony Brook University in the OpenMP programming language committee. And if anyone is interested in OpenMP in your application code, feel free to reach out to me via the email shown here, and we can figure out how OpenMP can be used for your application to get your, the performance skill. Thank you. Yeah, please.
What's going on there? Wow. All right. I don't know. Is this going to work on like a laptop GPU as well?
Yeah, it will, as long as you have a GPU.
Yeah. What's the gap between the performance you can get with OpenMP now and sort of like the best handwritten, like CUDA or something?
You mean the performance gap between OpenMP programming application versus the CUDA? So we do have a couple of benchmarks that show that there is basically no performance gap between CUDA and OpenMP for some applications, for sure. Yeah,
for some applications. Okay.
Yeah, to be honest, for some applications, we all know it's quite challenging, and OpenMP is especially the programming architecture is different, right? So yeah.
Very good.
Yeah, it's already can handle it. Yeah. Sorry. The new challenge is, well, so to be honest, especially for this kind of code, right? Especially use the application right in a CPU standard, CPU way, it's not very efficient with run on GPU. We have to optimize it. That's our job, to optimize it without user change their code, without all the modification for the users. So that's the challenge, ongoing challenge, forever challenge, I believe. Yeah.
I'm not sure if that's the case.
Well, if ChatGPT can write C++ code or Fortran code, I'm very happy to hear that. So.
I mean, based on the experience of my students and me playing with this, you ask ChatGPT to write an OpenMP program to solve something, it'll do an amazing job. It's shocking. It'll be wrong. You won't know why it's wrong, but it will look really convincing.
That's how ChatGPT works, right?
Yes.
Yeah.
Any other questions?
Yeah.
Very silly question. What is the very small bar
Oh, your favorite one? It's back. So yeah, it's a module management. Yeah. Yeah.
Y-axis there,
You mean this one?
no, below.
below
graph,
y-axis.
what's on the vertical axis?
Vertical. Oh, these are just the different components, for example, programming models or some projects.
Yeah, that's horizontal. What's up?
Up the that the dependence, whether it's critical dependence or it's just important dependence, just the dependence ratio of the entire ECP project. This one MPI, y-axis.
Yeah, what are those?
Yeah,
values?
exactly.
Yes.
I think it should be from 0 to 100. So I don't. Yeah, it's too blurred here. So
Like the significant.
yeah, the higher the bar is, the higher the dependency, which means that all the ECP project depend on that. So yeah. So yeah, open that here.
Shilei, thanks for.
Yes.